PLC protocol has two mechanisms. Either it can be called as connectionless or it can be called as connection oriented. So let us see the scenario when it is called connectionless and when it is called connection oriented. So connectionless is nothing but frames are sent from the sending end to the receiving end. And these frames will not follow any order. These frames will not follow any order of this thing. So as I was telling that this is sender, you got the idea, and this is receiver, assuming that, and 10 frames were sent. So this is the receiver and 10 frames were sent. So frames were sent as say this was the frame number 0, this is frame number 1, right? This is frame number 1, and so on. 10 frames were sent. So this is frame number 9. So total 10 frames, because 1 to 1 to 9 are 9 frames, and this 0 is the 10th frame. But so 0th frame left first through this medium. Then from the sending source, first frame left, then second frame left, third frame left, fourth frame left. But at receiving end, you got the idea. What was received? The frames were received in the order. Say fifth frame was received first, then came the second frame, then came the first frame, then came the sixth frame, then came the seventh frame, then came the ninth frame, then came the 0th frame. Like this, all the frames are arriving out of order. That means here each frame is independent, is treated as independent, entity, and they are received by the receiver, not in the order in which these frames were sent, not in the order in which the frames were sent. So such type of what I meant to say methodology or process in which the frames were sent in a particular order, but they are not received in the same order as that were sent, is called connectionless protocol. Physical connection will be there, this wired connection will be there, but frames will not be reaching the destination in order. Some of the frames may not be received at all. Some of the frames may not be received. Say frame number 8 has not been received at all. So this is the scenario which is called as a connectionless, what I am to say, scenario. Right? Now we have what I am to say, the scenario or something like that, connection oriented scenario. In connection oriented scenario, logical connection is established between the source and destination. That means, suppose I meant to say there is a sending source, right? There is a sending source, right? There is a sending source, and this is receiving source. And between the receiving host and sending host, you got the idea, sending host and receiving host. I have, some 5 routers that were there. 5 routers, the traffic came through 5 routers. So the data came first here, and then it came here, then it came here, right? Then it came here, then it came here, and finally the data was delivered here. Data was delivered here. So this is the order in which you got the idea, the thing were there. So this is 3, this is 4, this is 5, you got the idea, this is 5, and finally this is 6. This is how there were 5 intermediate routers through which the data was received at so this is the receiver, you got the idea, this is the receiver, and this is the sender. In current connection oriented protocol, all these intermediate resources, I mean to say like routers, all 5 routers have to be reserved before sender sends the data packets. So they have to be reserved. That means this entire path, router 1 to router 2, then 3, 4, 5, 6, all these are to be reserved. And then first frame will leave. So the first frame, it goes via the same path as decided before the connection was set up between sender and receiver. So second frame will reach after first frame, third frame will reach after second frame, like that. So frames are received at the receiving end in a specific order in which they were sent. So this is called connection oriented protocol. This is called connection oriented protocol. This is called connection oriented protocol. So here all the frames, that somehow are related to each other in times of numbering, the time at which they were transferred, and that is there. So in this case, the frames are numbered, completely numbered. So first frame will always reach first, second frame will always reach second, third frame will always reach third, and so on. So data link layer protocols, these are the 4 protocols generally, but nowadays these last 2 protocols are not being used. So we will not study this. Actually, in next semester, that is 5th semester, you will also study go back NARQ and this selective repeat. This both protocols you will study in 5th semester. But as of now, and these 2 protocols, since they are not being used nowadays, we'll study only simple protocol and stop and wait protocol. These 2 protocols we'll see. Now, what is a simple protocol? Simple protocol is nothing but it can be treated as a finite state machine. Now, what is a finite state machine? Now, whenever, every finite state machine will have start state and one end state. Start state means it is the moment initial input when it is given to the system starts. The system starts. And based on the inputs received, it will go into various stages and do some action. So this is called finite state machine, right? I'll give you simple example of finite state machine where you have coffee vending machine, which is what I meant to say, which will take money from you. And instead, after taking the money, it will vend, or it will give you, 1 cup of coffee. So that I can treat it as a, finite state machine. So initial state is it will be on. That the coffee vending machine is on. It will be always on. In fact, 24/7 it is on. The moment it requires a 5 rupee coin or say 10 rupee coin to be inserted for making the finite state machine to go into a next state. So the moment you insert a 10 rupee coin into the coffee vending machine, it goes to the next state. It asks whether you want cappuccino, or you want filter coffee, or you want brew coffee, or you want instant coffee, or you want some varieties of coffees. So when you have selected say cappuccino, so the moment you select cappuccino, it takes a cup, that is a change in the state. Takes an empty cup, it fills it with what I meant to say, a little warm water, and then it fills it with milk, then puts coffee powder, and then starts, what I meant to say, nozzle, which will create a lot of bubbles inside this. So every time you got the idea, this state of the finite machine changes. And at the end, coffee is ready and cup is moved forward to you. And then you get, if you are given in excess of 10 rupees, it will return the excess amount. Or if you have given only 10 rupees, so it will take that. And it has served you coffee. And then the process ends there. So start will be there, end will be there. And with every set of input, say you have given the input as a cappuccino. So taking that input, it has changed its state and it has done accordingly. So this is what is called finite state machine kind of thing. So every finite state machine will take input and it will, go into several states. So here, assuming that there are only for our case, there are only what I am saying 2 states and 3 events possible. You got the idea? 3 events possible. So here, whenever an input is sent, the state changes to if any input comes at state 1, what it will do is it will do action 1, it will do action 2, and goes into state 2. It goes into state 2. So like in coffee vending machine, the moment coin is inserted, it has taken you to a screen, and where action 1, it has displayed you various coffee types. Action 2, it required your input that you have selected cappuccino. So 2 actions were done. You got the idea. So state 2. Now this what I'm to say, state 2 is there, and in this again you have given some input. So it does some action. You got the idea, and remains in state 2 only. Suppose this coffee vending machine has another scenario. If you want to have more number of cups of the coffee, so after delivering 1 cup of coffee, it will ask you whether you want more. If you say yes, then again insert. It remains in this only, state 2 only, and it takes the money, and then it gives the same cappuccino. You got the idea? Remains in state 2. And then finally you say, I'm done with, I don't want extra coffee. Now you have taken 3 coffees, and say after that it asks, machine asks whether you want another coffee. So you say no. The moment no, so this event, no action is taken, it is again bringing it to beginning state. So this is how it will happen. Of course, here I have not expressed it in terms of networks, but networks also somewhere like this, some of this scenario will happen. So machine will start in state 1. If event 1 occurs, so 2 actions will be taken, and the system moves to state 2. At state 2, there are 2 possibilities. If event input is what I am going to say given, so event 2 is performed. In the event 2, action 3 is performed, and if an input is given to state 2, which does what is simply it is called as event 3, and it has simply come to the original state. So this is what is a finite state machine. Now we have we will see the first simple protocol. You got the idea? So simple protocol, why it is called simple is it will neither have a flow control mechanism or error control mechanism. It is very simple. If the sender has a frame to send, it will simply send. You got the idea? So we are assuming here that receiver can never be getting choked. It will never get choked. Simply, it goes on receiving the frames, and sender goes on sending the frame. So this is the scenario, right? So how exactly this can be done is explained through the diagram. So here, this is the network layer. From that, the frame is formed at data link layer, and then sending node, it sends it. This is the logical link. You got the idea? And this is the receiving node. So in the receiving node, what I'm meant to say, again, if the data is what I'm meant to say, just from the receiving frame, the data is recovered and it is sent to the network layer. We have not checked any for error in the message. We have not checked for flow control and all, right? So this entire scenario can be expressed as what I am going to say, finite state machine, which will have 2 stages. So this is the stage, right? So packet from network layer, the moment it comes, make a frame. So the data link layer will make a frame out of it. And whenever the packet is pushed into from network layer to the data link layer, it starts and ready. And once it receives the DRAM from network layer, it converts that into frame by attaching header, trailer, flags, and all. And then it sends. The moment now here at the receiving end, frame arrives. The moment frame arrives, you got the idea what it will be doing? It starts. Then it will remove those flags at the beginning and end. It will remove that header and trailer part, and it will recover the data part. and supply it to network layer. This is what is done. So this sending source is never tired of sending the frames, and receiving source is never getting choked of receiving the data. It goes on receiving the data. It just goes on sending the data. So this is the simple mechanism of a finite state machine, expressed to finite state machine. The same thing. Let us try to uh, you know see through the diagram. Simple protocol. So in this simple protocol, you have this network. This is the time, and this is data link layer, and this is the network receiving node, and this is the data link layer. Now, whenever a packet comes from network layer, it comes to the data link layer. Now, data link layer converts that entire packet into a frame by attaching header trailer, and to distinguish between one frame with other frame, it attaches flag at the beginning, flag at the end. Then this packet is transmitted from this end to receiving node. So you can see here from this end it comes to the receiving frame. Moment frame comes over here, from this the original packet has to be recovered and sent to the network layer. So you can see here packet, so from the frame, that flag part, that header part, trailer part, everything is removed, and the packet is sent to the network layer. This is what happens. Now whenever next packet comes, you got the idea. Again, that goes as a frame, and from that packet is recovered, this goes to network. So this is very simple protocol in which nothing is happening. So frame is being sent and frame is being received, and no acknowledgement is being sent back by the receiving node to the sending node that yes, I have received the data sent by you. No acknowledgement. And this process, simple protocol, continues. Now we have another scenario. Second protocol is called stop and wait protocol. Stop and wait protocol, it enforces both flow control and error control. Enforces both the flow control and error control. So whenever a sender sends one frame at a time and waits for an acknowledgement. So one frame is sent from sender to the receiver. And the moment sender sends a frame, it will start a clock called as timer, and set the timer to, I have already discussed this, set the timer to twice the length of propagation speed, twice the length of propagation speed. If, before the timer gets timed out, if the acknowledgement is received from the, what I meant to say, sender, then what I meant to say, sender understands. Acknowledgement is acknowledgement is received by the sender, and who has sent the acknowledgement? Acknowledgement is sent by the receiver. That yes, I have received your frame. I have received your frame. So the moment acknowledgement is received, sender understands that whatever frame I have sent just now, you got the idea, and I have got the acknowledgement before the timer's time elapsed. Now it sends the second frame. Now another scenario is assuming that a frame was sent by the sender, and due to some reason the receiver has not received the frame, and it does not send the acknowledgement, because the receiver is programmed in such a way that only when it receives the frame, it has to generate acknowledgement and send it to the what I meant to say, sender. So it has not received the frame, it will not send the acknowledgement. It will not send the acknowledgement. So here at the sending end, this timer times out. The moment timer times out, what will happen is sender comes to know that the packet which has been sent might have got damaged, or it might have got into error, and what I mean to say, I have to send a copy of the same frame again. So that indicates that sender will always send the frame, and then copy of the frame will be always maintained by the sender. Why this has to be maintained? Because if the acknowledgement from receiving node does not come before the timer times out, that case indicates that the frame which was sent earlier, it got damaged, or something happened with that particular frame. So the copy of the frame, same copy of the frame, is sent again. So this can be explained through beautifully through example, right? So error control, how it is, whenever a frame comes to the receiver, it will always check whether the frame which has been received is in error. If it is received in error, it discards and informs to the sender that, I have, you got the idea, the frame was in error, you send the copy of frame. Or the second thing is something like, you got the idea. Uh, if the frame was received in order, I mean to say CRC, calculated CRC, and the CRC that is there in the frame, both were matching, indicates that frame came without error. So that, it will be decapsulated. Decapsulated means the flag part, header part, and trailer part are removed. Only data part is sent to the network layer. This is what happens. And an acknowledgement is generated by data link layer and sent back to the sender, stating that I have received the, what I meant to say, data. Now this is same FSM, finite state machine. So here the moment a packet comes from network layer to the data link layer, so what it gets into the ready state, and it makes a frame, it saves a copy and send the frame to the physical layer and start the timer. And here, whenever what I mean to say, there are two states at the sending machine, blocking state. So blocking state, what happens if what I mean to say, this timer timed out. That means within the specific time for which the timer was set, during that particular time, the acknowledgement for the sent frame was not received. So it knows, it goes into blocked state, and it sends the copy of the frame which was sent previously, just now. So it sends that. And, that's the scenario. Another scenario is it may get corrupted acknowledgement. You got the idea? If error free, now this blocking stage, when it gets unblocked, is whenever the packet is received on time by the receiver and acknowledgement is sent, and before the timer times out at the sending end, if the acknowledgement is received that frame went error free, in that case it stops the timer and discards the saved frame. Whatever frame copy was saved, it is discarded, and next frame is sent at the receiving end. Now this is the finite state machine at the receiving end, start state. So corrupted frame, the moment it arrives, it is discarded. If error-free frame is arrived, I mean to say CRC, calculated CRC, and the CRC which was sent along with the frame are same, then what will happen is it will take the packet, it will accept the packet and send an acknowledgement. So this is the entire scenario. Now let me take this is what I have explained already, all the things there. We will try to know through diagram. Just give me 2-3 minutes to finish this off, to understand this diagram. So this is, I have already explained, right? Now this is the example we have, right? So here in this case, this is the sending end and this is the receiving end. So packet which was sent by the network layer and pushed to the data link layer did what? This packet, it converted it to frame and started the timer. You got the idea, and sent the frame. And this frame, what was received, what I mean to say, by the receiver was found to be in order. That means error free. So the from the frame packet was received, data was received and sent to network layer, and acknowledgement was sent. Now what happens? Now second packet was sent. Now this frame, what was converted, timer has what I'm saying, started for this particular frame, but in between this frame was lost. Now what happens when the frame does not reach the receiving node? It will not act anything. It will not act anything. It will not generate acknowledgement. It remains silent here. It remains silent. No message comes. But here the timer times out. So within the specific time, that acknowledgement was expected to come, but which did not come. So a copy of this frame was maintained by the sender. It is resent again. The moment it is resent again it was found to be error free. So from the frame, packet was recovered, sent to the network layer of the receiving node, and acknowledgement was sent. Now what happens? Here, packet was sent from network layer to data link layer. Frame was formed, timer was started, and it was sent. It was this frame was arrived in error-free condition. So from the frame, the data packet was accepted and sent to the network layer, and acknowledgement generated. Acknowledgement got generated. But unfortunately, this acknowledgement got lost in the middle. Acknowledgement got lost in the middle. So no acknowledgement come, and timer at the sending end timed out. So what it will do, since the timer has timed out, acknowledgement has not come from the receiver, it will resend the copy of the previously sent frame. This frame's copy it will send. But now here, this particular packet is a duplicate packet. Frame this was accepted already, again duplicate copy of the packet. So here the receiving node does not have any mechanism to know whether this is a duplicate packet. So how do I avoid this problem of duplicate packet? Problem of duplicate packet. So it will how to do that. So for that, every frame, you got the idea, is given a sequence number. So this is again a small what I meant to say example given through this. Now here you can see the packet went. It was found in without error. So acknowledgement generated. Now here the frame was sent, but it was lost. So no acknowledgement came. So the copy of this earlier sent frame was sent, and it is frame 0 goes and acknowledgement 1 comes. What is acknowledgement 1 means? Here receiver tells that I have received frame 0. Now I am waiting for frame number 1. So frame number 1 was sent, which was lost. And it was not received. So no acknowledgement was generated. So timer timed out. So it sends the previous copy of frame 1 only. Now frame 1, whenever it is received frame 1, it generates acknowledgement 0, indicates that I have received the frame number 1. Send me, it sends acknowledgement stating that send me now frame number 0. So frame number 0 is sent. This packet goes off, and then acknowledgement was sent by the receiver, but this acknowledgement was lost. The moment it was lost, and timer timed out at sending end, this timer timed out. So it assumes that frame was lost, or it might have been received by the receiver, what I meant to say, in error. But actually a packet was received successfully. So it will send frame 0 again, So here frame 0, after receiving frame 0, this receiving node was expecting frame 1. Frame 0 only has come, so this discards this frame 0. It knows that it is a duplicate packet and it discards. In the previous diagram, that discarding thing did not happen. The same copy of packet was accepted. 2 copies of the same packet was accepted in the previous method. So acknowledgement 1, that means I have received the frame 0. Now send me the packet whose sequence number is 1. So this is the stop and wait. So here a frame is sent, and we will stop and wait for acknowledgement to come. And once acknowledgement comes, it sends the next frame. So this is how the whole thing